my name is Jack Dunaway. I work at Wyvern Labs. If you haven't heard of us, we create toolkits and put them on the Library Tools Network. So yeah, check us out on the Tools Network. So quick question, who here is CLAD? Raise your hands and keep your hands up. Okay, awesome, incredible, and keep your hands up. CLD, keep your hands up, and CLADs, keep your hands up. Okay, and CLAs, put your hands up. Okay, this is absolutely incredible. It looks like over half the room is certified. I want to hear it for everybody. Give yourself a round. So that is incredibly important to get LabVIEW certified. There's a lot of value in that for you professionally. If you have any doubts about it, come talk to me afterward. I'd love to convince you to get certified. Today we're going to be talking about LabVIEW dynamic events. Again, out of curiosity, who all is using events in their program? Oh, yes, you're doing it right. So how about dynamic events as the primary transport mechanism in your application, inter-process transport mechanism? Okay, it looks like maybe like a third, a quarter or so not quite as many hands. That's one thing that we like to shoot for, because events are an extremely powerful API for inter-process communication between your asynchronous processes. And so today what we're going to take a look at, oh, by the way, so you can join this. For those of you in the back of the room, you're certainly going to want to do this. Pull out your laptops, go to join.me/Wyvern Labs, and that'll allow you to follow along with this presentation on your screen. It's going to be extremely demo heavy. In fact, there are no slides in this presentation whatsoever. We are completely in LabVIEW the entire time. And so you're going to want to be able to watch that as we're demonstrating on the screen. So yeah, bust out your laptops, join me/Wyvern Labs, and that'll let you in. Even those of you on the front. So yeah, let's go ahead and dive straight in. So what we're going to take a look at first is just some of the basic syntax and semantics of the Events API, because it's probably familiar to a lot of you, but maybe we can shed a little bit more light, especially on the semantics. So the syntax is really pretty simple. All we have is 6 nodes here on the palette. The ones on the top are very loosely tied with the subscriber, and then the ones on the bottom are loosely tied to the publisher. And so first of all, when we're talking about messaging, we have the concept of a publisher and a subscriber, a producer and a consumer. And this is one really important aspect that we want to key in on today when talking about events. I started using events having come from queues, and I took that knowledge and I tried to apply it to events, and what I realized is that that previous knowledge didn't transfer, like there wasn't a perfect mapping between all the concepts from queues to events. So you take some of what you know about, and you're going to have to erase it before you really understand events really well. But one thing that's very, very important to understand is that the publisher and the subscriber are 2 separate entities with 2 separate lifetimes and 2 separate APIs even that intersect in certain ways. And we'll take a look at how that happens. So the basic syntax looks like this. Over here, we're creating the user event, and so that's equivalent to creating the publisher. The publisher can then generate messages or post messages, generate messages and post messages. It doesn't necessarily send messages, and we'll talk why send is not necessarily the greatest word a little later on. And then finally, destroy user event. I like to call this kill the messenger because you're destroying the messenger object. The mailbox object, which is up here, your registration object, has a totally separate lifetime from the messenger. Very, very important concept. Again, we'll take a look into some semantics, and things that this means. So on the top half, what we have is generally what a subscriber has. The way we construct a subscriber is using the register for events node. So when you look at that register for events node, you can think of it as a constructor of sorts. You're constructing an object that is listening to a certain message, waiting for it to be posted. And it can also listen to several different sources at once. So that's one way that is slightly different from a queue. For instance, when you have a queue reference, you wire that to a D queue or a flush queue. Those are a couple of ways to get elements out of that. Whereas with the Events API, you can wire many different messengers into one subscriber. And then moving right along, we have the event handler structure. It's called just the event structure on the palettes, but I like to call it the event handler structures because that's where your events, that's where the messages that are posted are handled. And then finally, we have the destructor over here. Whenever we unregister for events, that is when we're destroying the listener. We're saying we no longer want to listen for events. So any questions just on the syntax at this point? Yeah? So this is kind of familiar. I'm sure you guys have done it on this stuff. So let's move on into the semantics. So the syntax is simply what does the language look like that we're using for publishes. And the semantics is what is the meaning behind this language. And so what I've done is I've taken that exact syntax and then drawn some boxes around it to try to put some logical groupings around each of these different components. So first of all, let's look at in the lower right-hand portion of the screen over here. When I'm talking about different things that happen, I may use any one of these words: messenger, sender, producer, publisher, subject, notifier. Those are all loosely analogous. They have, you use different ones in different contexts, but they mean roughly the same thing. And then same thing for the receiving end: handler, receiver, consumer, subscriber, observer, listener. And each one of those is paired with the opposite term. So when you say messenger, you would typically say handler. Sender, you would typically pair that with a receiver. And again, all this code, this is all available for download today. If you Google the name of this session, user events, tips, tricks, and sundry, it should be the top result. It's in a GitHub repo. You can download that as a zip. So yeah, feel free to take notes, take pictures, but you can take all this stuff home. Really focus. So yeah, and finally, for those of you coming in, also I'd like to mention you can go to join.me/wirebird for those of you in the back of the room, and you can watch this on the screen. So yeah, let's get back to some of this logical grouping. So down here is the publisher, where we've got, I'm going to kind of fly through this. We've got lots of demos. This is the boring stuff. So down here where we construct the publisher, we do some things like define the data type. Up there is where we bind the publisher to the subscriber. So here we very clearly have the publisher object defined, or publisher active object rather. And then up there, the subscriber is also very clearly defined because it's where you handle the messages, and then it's also where you'll destroy the subscription. One thing that I call murky waters is where exactly is it do we bind the publisher to the subscriber? Because that has to happen somewhere in your framework. Does it happen on the calling VI? Does it happen on the caller VI? Lots of different frameworks do it lots of different ways. And so rather than putting it in either of these two clearly delineated boxes, we just call it murky waters and then put a framework question mark on it. Because some frameworks do abstract this from you in a method, so that you're never going to see this on the calling diagram. One good reason that you may want to abstract this binding is that you don't necessarily, you don't expose the user event refnum to the callers, because the user event refnum can be considered private data to the owning active object. But also, when I say active object, I might say actor every now and then, which is just generally an actor, not necessarily an actor framework actor, but also an active object could be a service or an agent. Different frameworks have different names. So one other reason that you may want to put the binding in the subscriber is because this event registration ref num, who's tried to expose that on a contain, like as the output of a contain. As you change the data type, you realize that that ref, you're going to have kind of some problems going back and mutating those contains to ensure that that interface still lines up. It doesn't automatically mutate, and it can be sort of tricky. But I do prefer to live through that for the reason that you're able to encapsulate your publisher reference, not allowing the calling code to spoof the active object, and then perhaps drop new messages when you're calling that. So let's continue on. Let's see. So also, when we're talking about events in LabVIEW, there are a few different kinds of events. There are dynamic events, which are also called user events. Some people call them custom events or custom user events. I like to call them simply events, because the other type is the VI server events. And that's what we're looking at over here. So like when you register for a value change or when you register for a mouse down, those are all VI server events. But a lot of what we're going to be talking about today are custom events. So if I say just events, it's typically the dynamic events. And if I say VI server events, it's very specifically these guys right here. So let's see, one other thing that blew my mind when I learned this was extremely powerful, was this right here. Who knew that you could wire a pink wire into the event registration on the, who knew that? As of Monday?
Yeah.
Okay, norm session?
Yeah.
Yeah, exactly. The semantics behind the ability to do that are incredible. It allows you to do some really powerful things, especially what I was talking about earlier. Keep that user event, the user event, private to the owning object rather than exposing it to the calling objects. So let's see, that's extremely powerful. And by the way, it can be expanded, of course, to have name. So we can wire this up. And there we go, the diagram's not broken anymore. One thing you'll want to remember to do is on the tail end, go ahead and destroy those event registrations, of course, once you are registered. If your application stays in memory, if that was one actor that goes away, like a UI, for instance, then you've created a memory leak. If your application was shutting down, then it's not too big of a deal. It's good. It's good practice to try to close those, but it's not the end of the world. We'll get into that. It could be the end of the world. Yeah, one other question.
I wasn't at norm session, so I don't know. Did he also mention that you can register for an array of user events?
Yes, you absolutely can. Do I show that? Register for an array of user events. Oh, right.
So if you put a for loop around that, generate user events.
Yeah, exactly. I think I have a demo later, actually, that shows that, and we'll take a look at that. But what Mr. Hoover just said is right in here, if you can see where I highlighted that fire, you could drop a build array in there and register for many different event sources of the same data type. They have to be of the same data type. If they're not of the same data type, did you know that you can cluster those two together and then wire it there? There you go. So yeah, you can do lots of pretty powerful things with this. Okay, final thing on semantics.
Question
yeah,
on
this
the
is an
bottom.
important one.
Question.
Sorry, that question.
I just wanted to point out that in 2013,
seen, you can also unregister events with a bundle of event roughnums. So you can bundle them together and wire them to the event registration roughnum. You can also unregister them as a bundle instead of having to do them separately now.
Exactly.
Starting in 2013.
Yes, that is Craig Smith. We can give him a round of applause later because he created events in IB about 10 years ago. So yeah, thanks Craig for events. That's like my favorite API. I'm super serious. I absolutely love events. I'm crazy about it. So yeah, let's just compare events to the Q API for just a moment. So again, this is one of these very, very fundamental things that took me a really long time, years even, to really understand one of the major differences between the Q API. And I think that graphically, this shows it. A Q API, look, it's very linear, right? Your publisher is pipelining data straight to a subscriber. Whereas in the Events API, we have two parallel lines of execution. The one place where they intersect is where they are bound right here together when the subscriber is initialized or constructed. But then after that, they run asynchronously from each other. And granted, these two run asynchronously from each other, but in just a moment, we'll see that there is a type of control coupling. Control coupling, that's a term that Steve Watts uses to say two pieces of code that one's, who knows the best definition? Who knows Steve Watts here? The execution of one process can affect the execution of another process, and therefore they are coupled together. So we'll take a look at that. Okay, any questions on semantics? We're going to dive straight into 12 or 13 different examples, and we'll have to go through those fast. Yeah, Andy.
It's not semantics, but I heard from a reliable source that queues, notifiers, and user events use some of the same calls under the hood. So you can expect similar performance.
Yes, and we're going to see, so what Andy mentioned is that queues, notifiers, and user events likely use some of the same mechanisms under the hood. And so it's likely we can see some of the same performance. We can investigate that further, but one of these demos we're going to take a look at is performance, exactly. So yeah, let's dive straight in. So this demonstration, I'm going to go ahead and run it. What we're watching is this graph right here. It shows the memory that is being consumed by this VI. And one thing you'll notice is it's pretty flatlined right now, right around 0 megabytes. And so if I register a subscriber, we notice what is essentially a memory leak, right? Because I have subscribed for events, but I'm not handling them. Perhaps it would be nice to take a look at this diagram right quick. So what we have is we are creating a publisher over here. We've got a loop, and every single iteration in the loop, we're publishing an event. And we are subscribed to it with an A listener and a B listener. So we have two separate listeners. So already, here you're going to see some difference from queues. We have two subscribers to one event. So we have a 1 to N relationship here. One publisher, two subscribers. So the code, very simply, we have 3 separate buttons for each of the 2 subscribers. The first one registers. The second one suspends that registration by wiring in a null publisher. And then the third one destroys the listener. And so if we go back over to the code, what I had done originally was register to allow that to rise. Right before we took a look at the block diagram, I clicked suspend. And so now if I click unregister, what's going to happen to this memory? Who knows the answer? Everyone said stays. Everyone is wrong. Who said 0? Is it going to go to 0? Yes, it's going to go to 0. Why? Because when we destroy the listener object, we destroy all of the messages that it has cached in its mailbox. So this is a little bit unlike a queue. Well, no, a queue. If you destroy that, you're gonna lose the mess. You're gonna lose the memory that it had associated with it. One difference between queues and events, however, is that queues take the high watermark of memory that has been allocated to them. And so I think if we had done that with the queue, we may have seen it up there, even though it would have no elements anymore. So no more elements, but it would still keep that memory reserve. Can somebody confirm or deny that? Steven or Craig, or do you agree? We'll say I'm right then. Okay, so let's do another interesting test. Let's register A. Okay, see this slope? We'll call that N. If I click register B, what is the slope going to be? Who says N? Who says 2N? Who says 2N? Okay, oh, I had the answer. Who says 2N? Okay, so half and half. I'll go ahead and click it. But, oh, it's not good choice. What a terrible demo. Sorry, guys. Okay, let's try it again. I talked too long. Okay, I clicked A, so I'm going to click B. What's going to happen? Click B, and it stays exactly the same. One thing that we noticed that's absolutely crazy is that, so I just suspended A, and notice it's still rising. I just suspended B, and finally it goes flatline. One thing that this tells us is that whenever we are registering for one publisher with multiple subscribers, the Events API is kind of smart under the hood. It does not duplicate the memory until the event is handled. It is not released from memory until all instances of that event have been handled by all the handlers. So that's very important to know, is that it's not duplicated in memory until you handle it. So, yeah, sure.
It sounds like it could really problematic, one guy can slow, one guy that's not. Is there any way to tell which one is not handling the next?
Yeah,
Sharing the same memory.
you would look, well, it's sharing the same memory. However, when it goes to handle the event, so let's say you have one event that's fired to five subscribers. Okay, and so I'm going to talk anecdotally, my anecdotal understanding. It's going to copy that event data, and it's going to increment a counter to 5, okay? And so every time you handle, it's going to copy the data in decrement, copy the data, decrement, copy the data, decrement, until it gets to 0, and then the data goes away, message goes away. So you're certainly not going to see any problems with this. And then one other question?
Well, why does it start with -10 then?
Oh, -10? Oh, it's inexact. It's using a .NET performance monitor, so you know .NET. Yeah. So yeah, any other questions here before we move on? Unregister. Oh, that was another demo. So notice I unregistered A, and it dropped back to this level. That's because we had registered B first, and we could see the level at which we registered A. So all of those messages that only A was registered for just got dumped, but it's holding on to those for B. So I accidentally did a great demo of what you just asked. Yeah, question?
You register for an event, and back upon that event, why is the memory still being used? Why is that event going away?
These events are not handled. So if we go over to the diagram, notice no event handler structures are here. And this is a contrived, this is silly, you would never do this, you would never publish events. But yeah, this is contrived just for the demo. So yeah, let's go ahead and get out of this and move on. Dynamically registered events can be rebound to handlers. Okay, so yeah, we'll talk about it briefly. So what we have going on right here is we have 2 publishers, and we are registering two subscribers, and then we have 2 different modes of operation in this DI. In one mode, see there's a case structure in here. it's going to perform the swap function every single iteration. And in the other one, it's very, very simple. It's just going to register, not perform the swap. And so, rebind each iteration. I'm going to keep this as keep original binding. So if I run this, we'll notice that one is monotonically incrementing and one is decrementing the whole time. So who can draw in the air what's going to look like if I turn it to where we swap registrations each time? Well, first of all, who has ever dynamically swapped registrations between event structures or knew that you could? Craig, the guy who invented events, is the only one who knew that. So yeah, this is specifically, I wrote this example specifically because of one line in the help document that says I don't want to quote it because I'll get it wrong, but it basically says for each event handler structure, you must explicitly tie it to one event registration node. And I'm like, that is so not true. Events are so much more powerful than that. We kind of show this in a way. So what is one? Okay, so who can draw this? Where you're swapping each time? What's it going to look like? Anybody? Any guesses? Boom, got it. Right there, right in the back. It's going to look sort of like a bow tie. Swap and rebind each iteration. All right, so it is neither, just give it a little more resolution. It is neither monotonically increasing nor decreasing. It'll hit one at low, one at high, one low, one high, one low, one high. And that's because each time in the loop, we are swapping the binding between different event handler structures. And when I say binding, I'm specifically referring to one point in time. That point in time is right here. So when you have this wire, this event registration wire, it is unbound to a handler. It is not yet ready to be handled. Not until you wire it into the node right here. And at that point, it's bound and ready to be handled. So yeah, you can dynamically rebind registrations to different event handling structures. Any questions on this? Why would you want to do this? One reason you might want to do this is if you have an active object that's about to go out of memory, yet it has unhandled messages, and you want to broker those messages to some new owning object who is now in control of whatever that other object is no longer able to handle. So very, very powerful semantics. Okay, ooh, here's one. The effect of branching in event registration runtime. Of every example, this one blew my mind. I could not believe the results. So what we have here is two different modes of operation. Here we have the unique, good way and the shared, bad way. So everyone has probably heard this. Do not branch your dynamic event registration wire to different event handlers. And I was thinking to myself, that probably sounds just like a best practice thing, like they're trying to keep newbies from shooting themselves in the foot. I was thinking, this would be one really clever way to parallelize your handler, right? Because you can do that with a queue. You can have different consumers to one producer. A queue can be end-to-end. You can pick it off in different loops if you want to handle them in parallel. No problem with that, right? Or does anyone have a problem with that? Yeah, you do? What's the problem? But if they are independent of each other, if they don't need to be serialized, like for instance a web server receiving requests from multiple clients and those clients don't know about each other, order doesn't necessarily matter. And so it's okay to parallelize. So it's actually okay to have multiple dequeuers on a queue. I was thinking, let's just try doing it on an event registration. So let's do it the good way. The good way, it's going to come out perfectly linear every time. It's publishing points from 0 to 300. So the bad way, oh, let's change it over to the bad way. Whoa. Not only that, one thing that's incredible about this is if we run it enough times, we'll see sometimes the value shoots up above 300. Well, it's not doing it on the machine today. When I demonstrated this at the CLA Summit in Paris, every now and then, this number 300 would jump up over 10,000, meaning that it handled 10,000 different events. And we're only publishing 300 here. Oh, yeah, you're right. Thank you, I forgot that I put that indicator there. Sum of events handled. You see that sum of events handled? Or wait, sorry, total events handled. 3 times 300 should be 900 every time, right? Agreed? You see it having 4 digits every now and then. So we're handling more events than we're publishing, and sometimes we're handling fewer. It's bad, it's crazy. Craig, yes?
Some of those might be extraneous timeouts, and that should be, I don't know.
Time-
I want to point out that these two things, this topic and your previous topic are related.
Yep.
I mean, the fact that you can swap event registration rectums on the fly is the reason that we can't deterministically make all the event structures handle the event. We don't
Because
know.
it's a race.
Right, we don't know
I never
ahead of
thought.
time that the same event structure that handled the last time is going to handle it next time. So we can guarantee that at least one event structure will get the event, and if, while that event structure is running, another thread in parallel also handles it, that's fine. But all we can do is watch the event count, the handler count went from 0 to 1, so someone's handling, and then it goes back down to 0. But we can't guarantee that it goes up to however many event structures could handle it, because we don't know that all of them will, because it's data flow, and it's basically the alpha problem to figure out who's going to execute it the next time.
For those of you who couldn't hear it, Craig just said, "Don't do this ever." It's not. Okay.
But I don't even know if you realize that the reason behind this is because of the last topic. So.
Okay. I've heard people say, "I don't use events. I use queues because queues are pretty fast. Queues are fast and events are slow." Has anyone else besides me heard that argument? Yeah, a couple of people. They're not. Okay. So this is a VI running on a VM. We're getting data throughput of 20. Okay, yeah, false. They're not that slow. There we're getting a couple thousand events per second, data rates in the double-digit megabytes per second. And guys, this is running on a VM on a 1.6 gigahertz dual-core machine, 2 gigabytes of RAM. It's pretty bogged down even trying to run this. Run it on a modern desktop and you're going to get even far better than this. One guy, Steen Schmidt in Denmark from G-Power, says that he even uses events on RT, and he's gotten data throughput of better than hundreds of thousands of events per second, like on C-Relay. Yeah, question, Ian.
So I used to think it was slow because I thought they would bounce to the user UI here. Is that true? How does the UI do that?
So I don't think so. You're probably thinking of VI server events, which may be a little bit slower. Like if you tried to do 1,000 value changes, you know, sending data through a val change on a control reference, that's not going to get anywhere near the performance of the native events API. So yeah, that was a quick demo. Looking at the block diagram, it's just as silly. It's simple. It's Okay, here, let's see. This was more of an actual benchmark of, and we won't dive into this because it's a little bit small and hard to read. This was more of an actual benchmark of queues versus events. And what we find is that when we have, I tested a 2D matrix of message size versus number of messages. And what I found was that as both of those increased, the ratio of speeds essentially converged. Events always were just a little bit slower. So if you are truly pushing the limits of your transport mechanisms, you may want to use queues. However, to say that they are not performant enough for your just general application architecture, that would not quite hold true. It's only in the most performant of cases where you would want to use queues over events for performance reasons. And this is in the repo. Feel free to study that at home. Draw your own conclusions since benchmarks, you know. Okay. Yeah, so what this does is it tries to characterize the performance of posting a message based on how many subscribers are subscribed to that message. And so taking a look at the block diagram, what we have is a for loop. Well, first of all, we have one single publisher who is going to be publishing 100 events. Serial events from 0 to 99. And what we're going to do each time is add one more subscriber. So in this outer for loop, we're going to run the benchmark with simply one subscriber for those 100 events. Next time, 2 subscribers, all the way up to 500 subscribers. Sorry? Oh yeah, that's a good point. We're starting with no subscribers. Ooh, and that brings up some fun things we're going to take a look at later. 0 subscribers. So up to, I guess, 499 subscribers then. So let's see that generally, there's a little bit of noise in the benchmark, but generally it kind of linearly goes up. The more subscribers we have, the longer it's going to take to post those messages. But even still, looking at the absolute values, posting 100 messages to 500 subscribers, somebody help me with the math, 50,000, is taking about 30 milliseconds on this low powered machine. So the absolute value is still very, very small. I would say it's pretty uncommon to have 500 subscribers to one event. Typically, you're going to have 2 or 3. Maybe a file logger, maybe like a network repeater, maybe a UI, for instance. I don't know, who has done like lots and lots of subscribers with user events? Brian? 9? Yeah, that's quite a few. But even 9, you're not going to see that big of a hit. Oh, here's another fun one. So this goes back to, I think, about 2008. Tom Clark in the Netherlands characterized this first, I believe. Or maybe it was Norm, not sure. They said, wait a minute. I'm not achieving deterministic handling order between events. And there became a rumor that kind of spread around that events coming from different sources, you could not synchronize the timing, even if you guaranteed that you were posting them serially. So it was saying that you could post, basically you could post 2 events serially and guarantee that, but you couldn't necessarily determine on the receiving end what order they would be received in, where, ostensibly that should be deterministic. So let's go ahead and just run the demo, and then we'll take a look at the code. So what this code is doing is it's sending an event that simply alternates between 2 values, between 0 and 1. Okay? And so what we see is a pulse train on all three of these that looks deterministic, right? It's up, down, up, down, up, down, up, down, and that's exactly what we would expect. That's because we are generating events greater than 1 millisecond apart. That's an important concept. Let's change it to where it is sub-millisecond. So in other words, we're firing them all off just as fast as that process can handle it. So let me run it again. And whoa, that's not good. So what it means is when we're handling these, we're handling several downticks, several upticks, several downticks, several upticks at a time. Whereas down here, it remains deterministic. So something about these two is non-deterministic, and then this one is deterministic. Craig?
You're running 2012, right?
Sorry?
Is this 2012?
Yeah, it is.
Okay.
Yeah.
This no longer should happen in 2013.
It no longer happens.
It should.
Really?
I'd like to get your opinion on make sure that that's this particular case, but
Awesome. That's incredible.
that race condition is fixed basically.
Okay, cool. So let's see how we generated this. So these three graphs are generated in. By the way, how are we on time? Doesn't matter. I heard doesn't matter. Those of you in the back are groaning. So we're registering for events in 3 different ways. One is when the control reference and the user event reference are both wired into the same register for events. One is implicitly registered by going into the configuration dialog of the event handler structure and saying, register for the val change event of this controller. And then the other one is registered dynamically. And so the way we're publishing events over here is we're publishing to 2 publishers. We have the event right here, and then we have the control reference that we're firing the value signaling on. And that's what we see over here. We're firing always the event first, and then the VI server event next. So it should be up, down, up, down, up, down, up, down in the handle. But what we saw earlier is that's not what we saw. So the only one that actually is getting it right is this one right here. It's when we create that mailbox with the dynamic event registration of the val change on this control ref, when we put that in the same mailbox as the dynamic event. So it's a little much to take in. This may be one you want to stew over at home. But if you ever find that your events seem to be coming out of order, look into this or upgrade to 2013. Yeah,
It is fixed in 2013.
It is fixed in 2013. So yeah, incredible. I can throw this demo away. That's good. Okay, here's a quick one. Turn off lock panel to allow asynchronicity. Okay, so when you go into the event registration configuration dialog of an event handler structure, right click on it and say configure events that I want to register for. There's a little tick box in the bottom that says, what does it say? Lock front panel until this event completes or something like that. So that's kind of, as I understand, it's kind of a legacy feature that makes sure that while that event handler structure is operating, that the user isn't saying click okay, come on, and then queuing up that many number of events. If that handler is taking a little while to do. So if you were to uncheck that and the user were to click okay, it would queue up that many number of events. So this is a bug that actually bit me for about a month. I was developing deploy, and there was this bug that happened every now and then where the entire IDE would lock up, and I couldn't do anything, and I couldn't reproduce it. but I finally narrowed it down to the fact that that checkbox does not just exist on the configuration dialog. That checkbox exists on each one of these elements right here also. So every time we drag this node to be larger right here, we can right click on each one, and this menu option right here, lock until handler completes, exists. So I was coming from the mentality that, oh, and this is only for VI server events. This is not for dynamic events, because we typically don't, we typically don't associate dynamic events the same way we associate UI and VI server events also. We typically don't need to lock it like that. But this particular one got me because I was so used to working with dynamic events, and then all of a sudden needed to do a dynamic event registration of a control reference, and I didn't realize that that existed. So just be aware that exists. And so doing the demonstration, all I'm asking the user to do is increment this to 5 to exit the program. So it's a simple task for the user. And if I click up, notice how that depressed and stayed depressed. So if I click up, it's locked. That front panel is locked. So I'm going to stop this diagram right here, and then right click here and uncheck lock. Oh, okay. That's actually a very good question. And let me turn these back on. If you're handling the event, it will unlock the panel. So that's why I have this goofy demo contrived like this. This one is being handled, right? It's bound to the handler, and so we're clearly handling events here. This one, however, is unbound. Which, is that okay? Is it okay to leave them unbound? Absolutely. Because in the control logic of your application, you may bind it at a later time in your application. You want to pre-register your mailbox to ensure that you don't lose events prior to the fact that you're ready to handle them. So yeah, this is completely valid. However, it's invalid in that one setting is messing us up since we are not handling the event. So if we turn off lock panel and then run it again, click up, down. So yeah, just be aware that one thing exists. And in the rare case that you run into an architecture that gets you here, check into that if your panel starts there. Any questions up to this point? Yes?
Okay, so the reason for me we use the VI server
Exactly. The question was, typically when you register for VI server, it's not necessarily just to do value change on a control reference. It's to do more powerful things. In the case where that bug existed, I was registering for the app exit event, which is not, it's a user operation, but it's clearly not just like a front panel control thing. So let's see, let's continue to run really quickly. And we are getting close to going over on time, so I'll try to wrap up very quickly here. What are we looking at here? We're looking at an example where the generation rate exceeds the handling rate. And so this design pattern is generally called the dropped frames pattern. So if we change things while this thing is running, notice that the number of drop events is raising at this point, because what I've done is I've introduced an artificial delay on the handler side. If I get rid of this artificial delay, drop events dropped events stops because we're not dropping events anymore. Our handler is able to keep up with our publish rate. So let's take a look at, let's see, how do we handle this? Let's look at block diagram really quickly. Oh, okay, right. Here's the demo. The demo is, even though we are dropping frames, the general shape of the waveform does not change because we want to periodically basically alias that waveform so that we get a representative sample of what it looks like. We don't want events to continually pile and pile and pile up. If the handler is not able to keep up, and if we don't mind a lossy transport mechanism, then take a look at this drop frames design pattern. We won't go into it too much. Feel free to take a look at it later on. Let's see. And then the other example is when we do want to keep up with every single event, even though we can't handle them all at once. This is a case where it's very expensive to handle an event in that there's a lot of overhead per amount of data, yet the amount of overhead remains constant if you handle, say, 100 events at once. So if you have 1 unit of overhead and 1 unit of handling, then that means if you handle them one at a time, 50% of your time goes into overhead. However, if you have one-to-one, but you handle 100 at a time, then you're handling 100 events with 1 unit of overhead, so you have less than 1% overhead in the overall. So this demo, what we have is it's just a click and draw. So as I click and draw, I want it to update with every single point that the mouse has been. So this is like a simple paint program. However, it would be very, very, very expensive to draw every single pixel exactly as it's happening. So we defer, and we only draw every 50 milliseconds, and we dump the whole thing out. That's exactly the same concept as disk thrashing, like disk thrashing a hard drive. If you try to write 1 byte out serial at a time, it's going to take forever. But if you accumulate a kilobyte, push it out, kilobyte, push it out, much, much more efficient. Same with network traffic, and the exact same with events also. So later on, feel free to take a look at this design pattern, how to do that. One other thing we could point out is that events have some pretty powerful integrations with .NET. So this is a .NET control dropped into a .NET container, and we just click on that button, and it increments the 5 to exit. And the way we link .NET events back into LabVIEW dynamic events is through the use of the callback account. And who's used this a lot? Very decent amount. Okay, yeah, I see 5, 10 hands go up. So basically what you do is you create a VI that is called, from the .NET framework, that VI is called synchronously. So it's one important thing to know about these is they're very hard to debug. Can't turn on debugging, can't turn on probing, no breakpoints, because it has to operate synchronously. If you were to do any of these debugging things, it would lock up your environment. So again. But what we do inside of this callback is what I like to call the flaky delegate pattern. The flaky delegate pattern is basically, I don't want to touch it, here, you get care of it. So what we're doing is we're taking that data and then we're delegating it back as a user event. Was there a question in the back earlier? No? Okay, cool. All right, very final demo. Where's the event handler structure on here? There's no event handler structure. So if there is no event handler structure, and if I run this, then how is it that when I click on items, then I'm able to get this type of action if there's no event handling instruction? Well, the answer is what we've done is created a brat VI. Who's heard the term brat VI? Okay, why is it called a brat VI? Because it controls its parent. Yeah, exactly. So the parent VI is being controlled by the brat VI. The brat VI, what it does is it grabs a VI server reference through its parent, going up the call hierarchy, and it's in here is where we register for that event. And when we do that, that is what allows us to have functionality such as this. And then the way that we bind that callback to the event happening is here where we register event callbacks. So yeah, any closing comments or questions? Yeah.
I had a question on the binding for US blocking.
Yeah.
When you talked about it in terms of objects, what's a real world example of when you would do that? I never even knew you could do that.
Yeah. So when you have objects that are coming in and out, their lifetime is coming into existence and then going out of existence, if that object had tasks that were as yet unperformed, if it wanted to then delegate it back to another process, agent, active object, it could do so. A lot of times when you are killing off the process, you're also killing off any messages that happen to it. However, it gives you the ability to delegate it if those messages were important. And one very, very simple use case is simply a dialogue that pops up, the user dialogue. The user has control of the lifetime of that process because they can click the exit button or the cancel button, and then that process is going to go away. It may have had work that still needed to be done that it could then broker back to its caller or another process that it launches, actually. That's specifically the thing that I'm interested in, is when one dialogue launches yet another dialogue and then this one goes away. So it passes its work to its child that it instantiates. One more question in the back.
I was just curious if you fooled around with dynamic shared variable events.
No, not once ever. Sorry. Dynamic shared variable events. I've never actually used shared variables.
Okay.
Yeah, questions? All right. Thank you guys for